Hello, everybody. So let me see if I can advance this past this grinning picture of myself. Yeah, here we go. So my name is Simon Benjamin. I'm a professor of quantum technologies at the University of Oxford, and I'm also founder and CSO at a company, Quantum Motion. I'm here to talk to you in the former capacity, but the company will pop up. I've met a lot of familiar faces, including people that I haven't seen for a decade here, so that's been really nice. A lot of people know me, but I bet most of you don't know that I'm a bit of a nervous speaker, actually. So this is going to be a challenge. It's usually okay, but considering the venue, the size of the place, the lights, the music, I've never been played onto a stage before, and the small detail of following a legend, Scott Aronson, this is what I would consider to be nightmare material. So bear with me if I'm a little bit nervous or terrified, in fact. And that reminds me to say, in case I forget later, thank you to the organizers for putting me here. All right. So what is in this talk? Basically, it's a very wide-scale overview of what the UK has been up to for the last 10 years and what we're getting up to now and for the next 10 years. So as you can imagine, it's going to be a big picture thing. There's going to be a lot of entities that I mentioned. There's going to be a lot of acronyms, lots of numbers, this many million, that many million. And there's going to be a lot of logos. There's only 2 logos on this slide, but this is just warming you up. In fact, I'm not sure how this talk will be received, but if there's one thing I'm sure of, no one at the end is going to be saying, I wish there were more logos. So count them, if you like, as you go through. So here's my first slide, certainly an overview of the UK, 2 maps here. Let's look at the one on the left. It has a bunch of dots there, 4 dots, and each dot is something called a quantum hub. So these were founded first in 2014, and they are the backbone of how the UK has approached the problem of getting into quantum technology and taking, I think, a leading role there. Each hub is an alliance of universities, typically more than 10 universities, led by one of them, but matched also with a whole bunch of industry players. Typically, there's tens of millions invested from the government to get a hub going, but the industry players are putting in an equal amount. So right from the beginning, conceived as an academic industry environment. You can see, I don't know if you'll be able to read, but there are different themes. Only one of these hubs is on quantum computing. There's one on quantum networks, and then there's sensing and timing and imaging. So really a broad understanding of what quantum technology can mean. I think in creating these things was a bold move at the time, and it really put us into an interesting position. The second picture of the UK here, just quickly, this shows the money that went directly into companies that had or wanted to gain a quantum element to their business. And you can see there was government support and also a lot of private money going in. Okay, so what did that add up to? Let me just quickly summarize it for you. Over £1 billion UK over the last 10 years. And 44% of that in that first topic there, research. So that's the stuff the hub's got up to. That's how on earth are we going to make this technology work? Obviously, that's going to be your core. 25% on innovation. What innovation means is supporting companies to get into it. 22% on infrastructure. Here, the most interesting thing is something called the NQCC that I'm going to tell you a fair bit about later. And then the remainder, which is something over a quarter, in an absolutely essential area, which is skills development. I think I'm right in saying that there were over 570 PhDs that were created, people who were educated to that level, using these funds to create a workforce. And these are people coming from diverse backgrounds, not just the usual physicists. So where does that leave us, that decade of investment in all different areas? Well, you heard some of this from Jenny Bates yesterday, so I won't need to spend long on this slide. It leaves the UK in a pretty nice position. 3rd in the world for the quality and impact of research. 2nd for the number of quantum companies. And that's remarkable. We're not a big country. And I think 12% of global private investment going in. And just to reiterate, this is a broad view of quantum technology. Of course, quantum computing is in there as probably the single largest piece. But this is all kinds of quantum tech. OK, so let's look at some examples of what was achieved. There are 6 really cool things on here, but I think I'm going to have to cherry pick 3 of them to tell you about. If you'd like to learn more, just look for the UK Quantum Technology Challenge Directory. Those are the key words. And you will find there's a PDF there that lists these and many, many other examples. So I'll focus on the ones that aren't quantum computing related, because I'll come on to that. So the wearable brain scanner, what is that? Is that a ChatGPT mock-up of what someone would one day like to build? No. That's an outcome from the Sensing and Timing Hub, which was at Bristol, working with Circa Magnetics. And now they have installed what is the world's first portable brain scanner in hospitals. It's in Toronto, it's in Great Ormond Street, London, and is used to study specific problems, I gather, such as juvenile epilepsy. So this is quantum tech out there being used. Let's look down at the picture of London there with the famous walkie-talkie building and so on. This is to remind me to tell you that quantum networking has gone through a series of demonstrations at different kinds of geographic scales over the lifetime of the quantum communications hub, and culminating in a demonstration across London led by BT with Toshiba Cambridge as a major partner and HSBC as the fintech bank lead. And this network took commercial traffic. So now quantum secure commercial traffic is possible in London. They also, of course, work on post-quantum crypto and that kind of thing. And then just quickly, I have to mention this gas thing, because that's another one that Jenny brought up. So that came out of one of the sensing hubs, Quantic, and it involved bringing together work on single photons with extremely efficient detection to be able to detect leaks of specific gases that you are interested in or concerned about. And that, again, is a fully functional product. Those guys are now partnered with Schlumberger, which I gather is the world's biggest offshore driller, and they care about leaks, as you can strongly imagine, from their pipes. So this is quantum tech being used to stop nasty leaks in industry. So these are real concrete outcomes, and the others at different stages of development are similar stories. So this coming up to the present day now, where does that leave us? What can we say about where we are now and where we would like to be? Well, the philosophy over the last couple of years has been, let's ensure the UK stays in a nice, healthy position on the world scene. Let's try and make the UK the go-to place to start a quantum business. And well, okay, it may not sound as exciting, but the orange in the bottom right there, it is essential to have regulatory frameworks and to think about the ethics. This was mentioned yesterday a little bit. I mean, who is going to have access to all these wonderful quantum technologies? Is it just the usual suspects, the most privileged countries? Or are there ways to get it to help people more universally? But the pink one here is time for my first hot take, actually. So this might cause the people who invited me to panic a bit. But I'm going to say some things which are just my opinion and are not the opinion of His Majesty's government or Oxford University or any other large entity like that. I think that this fairly innocent one here down in pink, drive the use of quantum technologies in the UK to benefit the economy, society, and security. That means that we have to find not just some small number of examples, but pervasive use of quantum technologies, including quantum computing, for actually societally impactful stuff. And that's easy to write as words and very, very hard to achieve. So I would say that our quantum computers, even if we had the kinds of fault-tolerant machines that we currently dream of, more about that in a minute, we wouldn't necessarily be able to get societal impact out of them. So I think there's a lot of work to be done, as you were just hearing, of course, from Scott, on applications development. And I do believe that's going to get easier as the machines start to switch on and we're not just having to work out things on paper. So what has been going on since just the last 18 months? Let me bring you bang up to date. One highlight is the hubs are back. So they were working really well. They worked for 10 years. So you don't stop something that's working. But they've been completely refreshed. So it isn't necessarily the case that the hubs that worked before have got more money. They had to go through a competition. I'll tell you about that a bit later on. Another really interesting thing is that 40 million has been identified for test beds, and I'm going to tell you a bit about that. By the way, if you see the acronym PNT, that's position, navigation, and timing, and that's another very interesting thing I'm going to mention. And the UK has been signing international collaboration agreements with Canada, with the Netherlands, with Australia, Denmark. These are global quantum partnerships because, of course, we don't try and do these things on our own. All right, so Coming in 2024, or rather achieved now in 2024, this brings us really right up to the minute. The thing I'm most excited about is that those skills training initiatives that took place over the last 10 years to create a quantum workforce, we're doubling down on that. So we have 5 new centers for doctoral training, continuing, hopefully that, 570 doctoral researchers, and I hope it will take us way past 1,000 experts. The novel thing about these centers for doctoral training, if you're not familiar with the phrase, is they encourage students from diverse backgrounds. So historically, groups like mine would take on people with a physics background and occasionally someone from computer science or maths. These are broader-minded things, and they take people from engineering, electrical engineering, and they give them the full Monty in terms of what they need to understand quantum technologies and quantum computing in particular. International collaboration continues apace, and in fact, there's dedicated funding for joint activities between the UK and other countries, especially Europe. So go to the UK pavilion and ask about that if that might make sense for you. But now I have to talk about something I'm very excited by, which is the National Quantum Computing Centre. This is a facility at Harwell. What's Harwell? Harwell is the UK's main science campus. It's a 700-acre site, it's a vast site, about 30 minutes from Oxford, so very nicely connected to Oxford and other universities. It has multiple science technology clusters. One example is space technology. I think they have dozens of space technology companies clustered at Harwell, all delivering exciting stuff. The NQCC, the National Quantum Computing Centre, is the seed of a quantum cluster there at Harwell, aimed basically to be the focal point for the UK's quantum computing efforts specifically. And to kick things off, there was the testbed program, which is particularly exciting. So what's the vision here? The concept was for them to commission a bunch of quantum computers, and they have been commissioned. And they need to be all online by about the end of Q1 next year, so in a few months' time. Have a look at the systems that are listed here. You'll see that there's photonic, there's trapped ions, there's neutral atom, there's superconducting, and there's quantum dots. So a diverse set of platforms from a bunch of different companies. Several of them you've heard presenting this week. We heard from Rigetti yesterday that they're very pleased to say theirs was the first to come online. And of course, they're at different levels of maturity, so it's pretty interesting to literally have 7 different beasts like this in one building so that you can compare and contrast them. I think maybe the biggest might be the Q-era system, which will, I gather, have 256 qubits. But I can tell you the smallest in both senses, and that's the one from my company, Quantum Motion. That is what we call a scalable tile, really just a unit of a quantum computer with 4 qubits in it. But why that's exciting is that those qubits are at the scale of transistors, a few tens of nanometers across, and it's been designed so that it can be scalable, so that you can cover the surface of a chip at that scale, essentially achieving a miniature quantum computer. But against all these different philosophies for quantum computing, how would you set about choosing which one is best or most appropriate or most likely to be able to scale? That's a fearsome and interesting challenge, and Elham Keshefi is the woman who's in charge of delivering it. That her team will have to invent metrics, apply those metrics, and try and understand essentially these machines as a continual user of them and see which ones are worth really betting on for the UK. And that gels into the mission statements. So this is the big vision for the next 10 years. A whole series of missions. I'm not going to just read out this text, but I will talk about the first one, which is the quantum computing one, and perhaps the one that's of most interest to the people in this room. We heard from John Preskill yesterday about mega-QOPs, quantum operations, and that we were on the verge of having millions of quantum operations. Well, mission 1 here is not for mega-QOPs, it's for tera-QOPs, 10 to the 12 quantum operations. And we have 10 years to deliver it. So that is a proper beast of a machine. It's not the biggest quantum computer you can imagine, but that is large enough to really hack into some of the very interesting deep quantum algorithms. So that's a challenge. That's very clear. Anyone who's on the hardware side can be thinking, oh yeah, could I do that? Interesting. It's not dissimilar to some of the things DARPA have been asking the international community to suggest. But I would say that the big part of mission 1 that I don't understand how it will be delivered is actually the rest of the sentence. Let's read on. Supporting applications that provide benefits across key sectors of the economy. So as I mentioned, I'm of the opinion, and this is just my opinion, not the UK's opinion, that we need more algorithms, and we need those things to be co-discovered as the quantum computers get bigger, or else we'll have built them without an obvious use for them. So I really think that's perhaps the larger part of the challenge. Let's cast an eye over the remaining challenges. You see that there's an ambitious one on quantum networks at multiple scales. There's one on sensing, specifically for the NHS, so that's medical sensing, very specifically defined. There's one I'm going to mention a bit later on navigation, and then finally the idea of a network of quantum sensors that can be linked by either classical or quantum means, and the kind of things you can achieve, security issues, but also understanding what's beneath the ground, these kind of things. So a whole set of goals. Note that the 3, 4, and 5, we only have 5 years, or 5 to 6 years to develop those. They are on a shorter timescale. So this is a really nice set of visions, I think. It's the right sort of thing to be trying to do. How is that going to be achieved? Well, as I mentioned, the hubs are back, and they're back with these missions in mind. The hubs have similar flavors to last time, but in detail, they're planning to do different things. And there are 5. If you were paying attention at the beginning, there used to be 4. So there certainly is going to have to be something new. What's the new kid? It's biomedical sensing. So that one, and I'm really just reading here, it's aiming at advancements in quantum-enhanced blood tests, MRI scanners, even new surgical techniques, faster detection for diseases, and earlier patient interventions. And it's a hub that aims to really, perhaps even more than the others, serve as a direct bridge between the technology development and the users, which is the NHS, hospitals, and so forth. So let me just finish up by a quick look at the other, 3 of the other new generation of hubs, and you can see whether these are the things, kind of things that you'd be interested in. Here's the quantum computing one. You can see that its name is all about integration and interconnectivity between things. And that is for a reason, which is we feel as a community that we need to be able to network together pieces of a quantum computer if we're going to be able to get to that trillion-plus operations machine. Now, here's my take on that. Again, disclaimer, it's no one else's take but mine necessarily. I think there are 2 ways to get to those very big machines. You either miniaturize your computer onto a chip, which silicon could potentially achieve, or you do distributed QC. But since we can't be sure silicon will work, we should certainly be working hard on distributed. In the end, you'll always want to link quantum technology together to make a bigger computer, just as we do with conventional systems, despite their huge on-chip capabilities. Here's just a single slide with 2 of the other hubs. In case you are interested in what the network-orientated hub wants to get up to, there's a summary of it. Of course, you can read more about these things. They all launched in the last quarter of this year, so they've all got their websites up and lots of detail about how to get involved and so on. And finally, here's the quantum-enabled position navigation and timing hub. That's something that I never really took much of an interest in, if I'm honest with you, until I took a short break in Cyprus earlier this year. And I got off the plane and looked at my phone, and my phone confidently told me that I was located on the West Bank. And that was confusing to me because I was pretty sure I'd got on the right aeroplane. What was happening, of course, was that GPS was being spoofed because of I think spoofed is the right word, because of the conflicts there, and my phone was lying to me. Or more accurately, the reality that my phone perceives was lying to it. And that's, when you see that and you see how helpless you are against that kind of thing, you come to understand why it's interesting to develop alternative technologies. And the alternative here is that you have a device whose timing and accelerometers are so exquisitely good that you can have the thing in a reference location like London, you can move it around the world, and it will know where it is by inferring. That's an old method that goes back to the era of sailing ships called dead reckoning. So that, I think, is actually going to be an extremely important use of quantum technology, because we are always going to need to know where we are. Okay, so this is my wrap-up slide. It isn't really a summary of the whole talk. It's rather what I want to emphasize at this point. And what I want to emphasize is that everything I've shown you is with enormous amounts of international collaboration. So my own comment coming up here, Don't be put off by Brexit nonsense. The Brits are as keen to collaborate and as internationally minded as we've ever been. If anything more so, because most of us are angry about Brexit on the research side. So our doors are open for business, and some of the opportunities to get involved are listed on this slide on the left, or perhaps my talk about missions, hubs, test beds, and even centers for doctoral training, if there are young people that you know that would like to come to the UK and be trained. We are absolutely open for business. So please drop by the UK Pavilion and talk to us. Thanks a lot.